Hello, 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 ladies and gentlemen, and welcome back. Root Beer here. We're going to finish off the 2005 Galois paper with our last question, question number 4. The volume of a sphere with radius r is 4/3 pi r cubed. Okay, good to know. I believe the last time we did solids in high school was in grade 9, so this is, it's probably something you should know, but it's a great reminder. The total surface area of a cone with height h, slant height s, so that would be the height going up along one of the sides, or not one of the sides since I guess it doesn't have a side, but going up the slant or slope of the cone to the peak, s, and radius r is pi r squared for the base there, plus pi r s. Okay. So there is a relationship between S, H, and R there. That's why they have cone with height H, but I imagine we have to make that a connection ourselves. Okay. So we've got some geometric formulas. That's okay. I'm a little apprehensive just because, in my experience, I'm not the best with the 3D geometry problems. They tend to hang me up a little bit, but we'll see. We'll see where this goes. There's A part, a B part, and that's it. Okay, so a cylinder has a height of 10 and a radius of 3. Determine the total surface area, including the two ends of the cylinder, and also determine the volume of the cylinder. Now, they didn't give us a formula for either of those, but that's actually not so bad. I've had to explain this to my intro calc course a number of times, so we'll talk about volume and surface area of cylinders. B part. Just read this while we're here. A cone, a cylinder, and a sphere all have radius r. The height of the cylinder is capital H. The height of the cone is little h. So with little h and r, we could probably figure out this little s here. The cylinder and the sphere have the same volume. The cone and the cylinder have the same total surface area. Prove that h and h cannot both be integers. Okay, so first intuition, we'll come back to B. I imagine B will be a bit involved just because question number 4. It's the last question, so it's hopefully the hardest thing. I'm going to guess that we could probably get like capital H in terms of little h, and it's something like little h times root 3, or little h times pi, or something like that, or little h times pi by 4, or something. And so then that would force them not to both be able to be integers. So that's what I would be looking for. Maybe capital H is little h plus root 2, or something like that. Just thinking of ways that we can get a relationship between the two and show that they can't both be integers. Okay? So that's sort of the general attack plan. Now, I find that it's a good idea to read all parts of the questions, especially for later questions. Question 1, you're not going to have too much of a problem. A, B, B, and C, they're not going to be super connected. This is more a comment on sort of all of Waterloo's written contests. But you'll find that for question 1 and question 2, the questions are, the A and the B are sort of a little related. But for later questions like 4 on a Hypatia or 9 on a Euclid or 4 on a Galois here, the A part can very much lead into the B part. So that's why I chose to read both A and B at the same time there. Okay. So we got to focus on A. Now, I don't know how much justification they're going to want in terms of the formula for total surface area. But we'll give a little bit. We'll give a little bit. So we want total surface area. We want the volume of the cylinder. So I think it would be okay just to say here's the formula for the volume of the surface area of a cylinder. Formula for surface area of the cylinder there, but we'll justify it a little bit. So I'll put an R here. So for a cylinder, with height, we'll make it capital H just because we've read ahead and we know that that's what they sort of want. So with height capital H and radius little r, volume is h times pi r squared, and surface area is we get pi r squared for the top plus pi r squared for the bottom. And then when we take away the top and bottom, imagine this were hollow. If we sort of got some scissors out and cut along just one of the sides, we could sort of unroll the whole thing. And we'd unroll it out, and it had a height of h, and it would unroll sort of from this point and go around. And so we get a rectangle here, and one of the side lengths is h. What is the other side length? The circumference of the circle, so 2 pi little r. And you could put that more into words, but it's a little vague as to what they want us to justify. They gave us some formulas, but I mean, 4/3 pi r cubed, that's one that people know, or people should be knowing. So surface area of the cylinder, that one you might not know as much, but certainly volume of the cylinder is fair game. But either way, so for a part, so for r of 3 and h of 10, by the way, we can simplify this. There's lots of ways to simplify it. You can do 2 pi r, r plus h. That's a fine way to do it because you get 2 pi r squared here, and then you got a 2 pi r, so you get the r plus h. That's a fine way to do it. I see other people do 2 pi r squared plus 2 pi rh, and that's fine too. It separates the top and bottom and the drum a bit. That's fine. However you want to do it is good. I'll do the first formula, 2 pi 3 plus 10. So this is going to be 6 pi 39. I don't know what 6 times 39 is off the top of my head, so 6 times 39 on my calculator. 234 pi. And volume is 10 pi 3 squared, so this is 90 pi. Okay. Maybe put a little box around them, or therefore statement saying therefore the surface area and therefore the volume, but we got the formulas, we stated them quite clearly and generally as well, and we just applied them. That's not bad, that's not rough. Okay. It's B part that should be the challenge. I'm hoping it's a challenge. So, we got the total surface area, we got the volume, A part's done. Now, a cone, a cylinder, and a sphere all have radius r. I'm going to draw pictures of these fellas right now. So here's my cone, radius r. Here's my sphere, radius r. You might even want to do one of these with the little dashed lines behind it. There it is. And we have a cylinder, radius r. And then we had some heights as well. The height of the cylinder is capital H, the height of the cone is little h. Okay. Cylinder and sphere have same volume. Cone and cylinder have same total surface area. Alright. So we have formulas both for the volume and surface area of the cylinder, and then we're given volume of sphere and total surface area of cone. So we know that 4/3 pi r cubed is the same as volume of the sphere, which we're told is same as volume of cylinder, which is h pi r squared. So we'll put pi r squared h here. Right? It was that cylinder and sphere have same volume. Okay. So now if I take out the pi r squared here, so divide by pi r squared, divide by pi r squared, we get 4/3 r is equal to h. And we'll probably be able to get little h in terms of r, maybe. I don't know. We'll see. Okay. So now we have to do a little bit of setup to get the s. So we can see by dropping an altitude of the cone, then we get h, and we get a little r here. Then s squared is little h squared plus r squared. Okay, so what do we need? We need little s, so we get r squared plus h squared here. Okay, so we know the, so let's keep that going. 4/3 r is capital H. Alright, so we know the surface area of the cone is, so what was it? It's pi r squared plus pi r s, but s is of course the square root of h squared plus r squared. So that's the surface area of cone, but we're told that that's the same as the surface area of the cylinder, which is 2 pi r squared plus pi r capital H. Okay? Oh, 2 pi r capital H. Okie dokie. So, yeah, same total surface area. So what can we do? Well, we can clean up a little bit. I can divide both sides by pi r. We'll get r plus the square root of h squared plus r squared. Get rid of a pi r here, so that'd be 2r plus 2h. I can get rid of an r. So root h squared plus r squared is equal to r plus 2h. What to do next? I suppose I can substitute in my capital H, so I'd get r plus 8/3 r, and that's 11/3 r. If I want maybe h, little h in terms of r as well, maybe that's the way to go. Let's square both sides, so 121 over 9 r squared. We can subtract by r squared on both sides, so we get h squared is equal to 121 minus 9, which is 112 over 9 r squared. 112 doesn't have a factor of 3 in it at all, so we're a little stuck there. But then h will have to be, and then we square root this. Now there are two options, but because h is a length, we only take the positive one. So we'll get 3 on the bottom, we'll get root 112r. So we take the positive one since h is a length. And so now, so we know 4/3 r is capital H. So let's get a capital H in here. So r is 3/4 capital H. Little h is root 112 over 3r, which is root 112 over 3 over 4 times h. The 3's cancel out. And we're left with root 112 over 4 h. Now there's a factor of 4 up here, I think. So yeah, 112 divided by 4 is 28. Oh, so there's a factor of 16. So this is 16 times 7 all over 3h. Root 16 root 7, because square roots distribute over multiplication. Oh, this isn't a 3, it's a 4. So that's 4 root 7 over 4, root 7h. So since little h is root 7 times capital H, they cannot both be integers. Now, I would say this is clear, but if you wanted to go a step further, you might say, since root 7 is irrational, then it can't be, well, it can't be a ratio, so it can't be expressed as a fraction of integers. But root 7 would exactly be little h over capital H. So they can't both be integers. That would be a fine way to say it. I think if you cut off here, that would be fine as well. But if you want to justify it, root 7 is irrational, and that's how we know that this is going to work out. Okay. So I think that's it. We were asked to prove it, and we did. We got formulas for these guys. We argued it down to a point, and then we sort of justified it. And maybe because they explicitly said proof, you want to use the root 7 as irrational. I'd leave it up to you guys, but it was what? An extra bit of writing, like one more sentence, 2 more sentences maybe. Not so bad. But that wraps up question 4, because there was no more of it. And that, I guess, wraps up the whole Galois paper. It's a little simple, I thought, this year, but that's okay. That's okay. You know, never complain about having a simple contest the year you happen to be writing. It makes your score look better, makes you look better, and it means you got a great chance of being school champion or whatever. Yeah, those are really my only thoughts. I liked the paper. Hopefully you guys did too. But I thought it was a tad easy. Usually I take a little longer on the 4s. Then again, it was the 3rd year of their contest. They're still working things out. But I look forward to the Hypatia for this year. And if you do as well, you can look for that on my channel. Maybe I have it up by the time you're watching these. Either way, it'll be up in the near future if it's not. Okay? But have yourselves a wonderful day. And, yeah, keep on mathing, I guess. Thanks for watching.